Om Shri Sai Ram. Dear students, having discussed so far about the concepts related to distance and displacement, let's continue further. So in this module 4, I would be talking of uniform and non-uniform motion. But before that, just have a close look at these two pictures. For example, in case 1, this car travelled 10 meters in every 1 second. So at the end of 1 second it is at 10 meters, at the end of 2 seconds it is at 20 meters, at the end of 3 seconds it is 30 meters. Now let's take another case. At the end of 1 second the car travelled 5 meters. In the next second it travelled 15 meters. And in the third second it travelled another 15 meters, which moved it to 30. So if you carefully observe these two cases, there is some kind of uniformity in the case 1. So in every second the distance is equal always. In the case 2, the time is constant, time is changing at the end of every 1 second. At the first second it moved only 5 meters, in the next second 10 meters, and then 15 meters, and so on. So with this background, let's define what is called a uniform motion. So when an object travels equal distances in equal intervals of time, we say that the motion is called a uniform motion. For example, have a look at this picture. All the cars are moving at the same rate, which means they are covering exactly same equal distances in equal intervals of time. But we know that this is a very ideal case. When we move on the road, this is not possible because there could be traffic, there could be speed breakers, etc. So therefore, we come to the second case where we see that some objects, they travel equal distances in unequal intervals of time, or unequal distances in equal intervals of time. Such a motion is called non-uniform motion. For example, have a look at this picture. If the car tries to maintain the same speed even when there are bumps on the road, this is what happens. This is an experience that people undergo. So whenever there is traffic or whenever there is an obstacle, our speeds vary. When the road is clear, the speeds are more. So therefore, these are the two kinds of motion: uniform motion and non-uniform motion. Equal distances and equal intervals of time. Practically, this is very rare to observe, but most of the day to day, this is where we deal with non-uniform motion. So one kind, when we say that objects are moving, so we say that they are covering distances in certain interval of time. So when an object is moving, as much the distance matters, the time also matters. And the parameter that relates both of these is called speed. And we also call it velocity, depending on few exceptions. Let's see what do these mean. For example, we would have heard this term, the bowling speed, average bowling speed in a cricket match. So they calculate this based on the distance and time. At the end of it, they calculate how much distance the ball has travelled and in how much time it travelled it. So the ratio of these two, the distance and time, will give us the parameter called speed. So let's define speed. Before that, let's try to understand. Different objects may take different amounts of time to cover a given distance. For example, we have seen, so when on a 100 kilometer, like on a highway, when we want to cover 100 kilometers, every person or every object may not take the same time. So some cover little distance in some amount of time. So whenever the road is free, the distance covered is maximum. When the road is congested or whenever there is signal, we have to reduce, the distance covered will be smaller. So therefore, the parameter relating distance and time is what is called as speed. So one of the ways of measuring the rate of motion, so we have seen this term rate. So we have seen this term called rate. Whenever we talk of rate, it is measurement with respect to time. So whenever we see this term called rate, it's always to be understood as the measurement that we do with respect to time. Rate of change of distance when we talk, for example, how distance varies with time. Rate of change of temperature, for example, when we say how does temperature vary with time. So one of the ways of measuring the rate of motion, so rate of motion, how the movement is changing with respect to time, is to find out the distance traveled by the object in the unit time. So you know an object has moved, at what rate it is moving, how is it moving faster or slower. So this particular parameter, which is speed, it will determine whether the object moves faster or it moves slower. So therefore now we come to this new parameter called speed, which is defined as the total distance traveled by the total time taken. Speed is nothing but the distance traveled per unit time. So this is how it is. Speed is distance by time, and there is a mnemonic to remember. The triangle distance, speed and time. These are not the actual symbols, this is a representative diagram. So distance, if you want to know, it is speed into time. Speed, if you want to know, it is distance by time, or from the equation, time will be distance by speed. So the SI unit of speed now we can calculate. Speed we defined as distance by time. The SI unit of distance is meters. The SI unit of time is second. So therefore for speed, when we want to write distance by time, distance it is meters, time it is second. So therefore meters per second will be the SI unit of speed. Of course, we can convert this into various other practical units also. So suppose the distance covered is in kilometers and time generally is measured in hours. So therefore speed is also expressed in kilometers per hour. So therefore, though there are various other units of denoting speed, the SI unit of speed is taken as meters per second. Now, once we have discussed with speed, let's see this. The rate of motion again. We see this term called rate of motion again. Rate of motion, now you know what it means. Rate with respect to time. Rate of motion, how the motion undergoes with respect to time, how the object moves with respect to time. Of an object can be more specified. The rate of motion of an object can be more specified if we mention its direction of motion. Now look at this. Till now we never spoke of direction. We only talked about how far the object has moved and in what time it has moved. So therefore, we have seen that just by calculating the ratio of distance and time, we got this parameter called speed. Now, we introduce a new dimension now. A new way of looking at things. Direction is specified now. If we mention its direction of motion along with its speed, this is important. So not only speed, direction. So on the highway we are standing. Suppose we want to go to a particular temple. We say take right, take left and go. Then we go to the particular destination. Suppose we don't specify. Suppose for example I am at point A and then my destination is at point B. When I ask somebody, and now let's take the directions as, so these are the directions that we take. So when I ask somebody where should I go to so that I reach the particular destination B, so they say that start from point A, wherever you are, head towards right or head towards east, so therefore you get it. Suppose they don't mention head towards east with 100 kilometers to 100 kilometers when they tell, I go to a particular destination of what I choose. Suppose they don't specify direction and they just said you go 100 kilometers. So starting from A, I can travel, if the direction is not mentioned, I can travel 100 kilometers towards my right or towards my left or towards the northern direction or south or any other direction. So it is more specified now. The speed is more specified, or the rate of motion, which is nothing but speed, is more specified whenever we mention the direction of motion. So direction plays an important role, and now suppose we are telling a particular speed of speed of an object. For example, an object is moving with 20 meters per second. So this only talks of the speed. 20 meters per second is just the speed. Now, if the speed is specified in the eastern direction, an object moves 20 meters per second towards east. So a particular extra detail that we are providing. Now it's more complete. So this particular way of saying, this particular way of defining, we call it velocity. So whenever we just mention the distance and time and calculate the parameter, the ratio of distance and time, we get this parameter called speed. Now once we got speed, if we specify the direction along with the speed, or along with, see, speed for example has two parts. One is the magnitude or the numerical value, one is the unit. If we mention speed along with direction, and this term is called velocity. So therefore the units will never change now. Speed and velocity both will have SI unit as meters per second only. But when we mention velocity, we are specifying the direction. Similarly, when we talk of displacement, we are specifying the direction in a particular direction from the initial point to the final point. But distance is not like that. So distance falls under one kind of category called scalar quantities, where there is no mention about direction. Specifying direction is not at all relevant when we talk of terms like, so whenever we talk of terms like distance, speed, temperature, etc., all these terms, we don't need to mention the direction at all. So between any 2 points, this is the initial point, this is the final point. Now to reach this is initial point, this is the final point. To reach point F, I can go like this, I can go like this, I can go like this, any way I can go. But if there is a specified way, if there is only one direction, there is only one way of reaching it in a particular direction, that is the straight line joining the initial and final point, this is called displacement. So the parameters like displacement, now what we spoke of velocity, and later when we learn about force, etc., all these parameters need something called not only the magnitude or numerical value, not only the unit, but also the direction. Displacement is in which direction? In the straight line direction from the initial point towards the final point, not away from it. So from here, when I want to reach F, I need to move in this direction in a straight line path. So this is displacement. Velocity, the rate is changing. At what rate the distance is changing and in what direction. So therefore, velocity we can talk of as speed plus direction. Displacement we can talk of or think of as distance plus direction, so on. So this is the main difference between these quantities. All these are called scalar quantities. Of course, more of this will be discussing in your higher classes. So scalar quantity means what? That particular parameter is not at all depending on the direction. It is independent of direction. And these quantities are called vector quantities. Vector means what? They not only need the magnitude, but they also need the direction to be specified. So whenever I want to talk of velocity, and then somebody makes a statement, the velocity of an object is 40 meters per second. It is wrong, because whenever we talk of velocity, we not only need to specify the value of 40 meters per second, but also in what direction. The displacement is 20 meters, in what direction is the next question to be asked. The force is so much, in what direction. So Direction plays a very important role when we are discussing with vector quantities. Of course, these two names you need not be remembering, but you should also know that there are parameters which also need direction to be specified. So if I just mention, suppose for example, when we just mention 20 meters per second, it is to be understood that this is speed. Suppose somebody writes 40 meters per second towards north. Now 20 meters per second, 40 meters per second, yes, but what is the extra detail? North, that is the direction which is being shown. So for these things, this is called the velocity. So whenever we talk of velocity, we need to compulsorily specify the direction. Speed and velocity, both of them talk of the rate of change of distance or displacement. So for better ease of understanding, this is how we take up velocity, the definition of velocity. Velocity is the speed of an object moving in a definite direction. It's nothing but speed, but with a specified direction. The formula for velocity, generally, because the motion is continuous, we keep on moving from point A to B, B to C, C to D and so on. So the total net displacement we talk of now. So for speed, average speed, we have total distance and total time, the ratio. For the average velocity, we have the total displacement. So point, it moved from different one position to next position and so on. It moved finally. Now, what is the way of calculating the distance in a specified direction to measure its displacement? So therefore, whenever we talk of average velocity, just calculate the net displacement. So for example, an object moved. So an object moved from point A, it moved to point B, then it moved to point C and point D and so on. So A, B, C, D, this is where the object has moved. Now I want to calculate what is the velocity. Now object started at A, finally it reached D. Velocity is what? The rate of change of the quantity, like how much distance it moved. For velocity we calculate the displacement because direction oriented. Velocity is also having the units of meters per second, but in a given direction. Time does not depend on any direction. There is no direction for time. So therefore direction has to be associated with this meter, that is the distance. So whenever we assign direction to the distance, it is called the displacement. So object started from A, initial point, it reached D, the final point. Now as it moved like this, the shortest distance in this direction is AD. AD. So if I know, so it moved all through, okay, but this is the displacement now. So an object started from A and reached D in a given amount of time. So what will be the velocity now? Displacement, the total displacement is what? AD divided by the total time taken. But if you want to calculate what is the total speed, so average velocity and average speed, two are there now. So when we work out some numericals, you'll be able to clearly make out why we are calculating average speed in a particular way, why are we calculating average velocity in a particular way. So whenever I want speed, I need to look for distance by time or total distance by total time. Whenever I want to calculate velocity, total displacement by total time. The formula is given, the SI unit of velocity. Just because direction is involved in specifying the speed, the SI unit will never change. Speed is measured in meters per second, so is velocity. This is also measured in meters per second. Meters per second. There is also another way of writing. So one way of writing is meters per second. People write like this. Or people also write ms minus 1. So whenever in the power there is a negative number, it means it comes to the denominator. So when I write a to the power of minus 3, it is 1 by a to the power of 3. So s to the power of minus 1, second to the power of minus 1 is 1 by second. So meter by second. So either you can write meters per second like this, or meters per second can also be written like this. So more on speed and velocity, let's try to look at this. The speed of an object need not be constant. Need not be constant. In most cases, the object will be in non-uniform motion. It can never be constant because day to day when we are moving, we can never try to maintain a constant speed. Because as and when, suppose the road is clear, there is no point in going at a constant speed. We have the option, we have a choice to increase the speed. Or whenever there is a crowded place like a busy market, we cannot travel with a larger speed, we have to reduce the speed. Otherwise, we have seen what happens. The rate of motion is described in terms of average speed. So therefore, as you move from point A to B, B to C, C to D and so on, so finally it reached from one point, it started from a point and then reached finally another point by traveling all these paths. So therefore, average speed we define as the total distance travelled, dividing the total distance travelled by the total time taken. The total distance we know, from point A to D we know total distance. The total time we can calculate, measure the time. So therefore the ratio of these two will give us the average speed. So average speed, so this is the term we see now. The total distance travelled by the total time taken. Now let's come to velocity. The velocity of an object can be uniform or variable. Velocity when we say, so from point A to D, it can be uniform, or there are cases where it can be variable as well. So when an object is moving in a straight line at a variable speed, now look at this, the object is moving, so right now we are only confining our studies to straight line motion. Object is moving in a straight line at a variable speed. So constant speed, we know it's very easy. When an object moves at a variable speed, we express the magnitude of this rate of motion in terms of velocity. Means what? We also specify the direction. So direction is included in displacement. So average velocity is the total displacement, net displacement by the total time taken. How much change of time? So from point A to D it went. Okay. So therefore, to move from point A to D, we need not go all the path length. We need not go over the whole path length. So from point A to D, just have a straight line traveling towards D. So from A to D. So that is the direction now. So total displacement. So in this formula, average velocity, they have not specified direction in the formula directly. But if we observe carefully, we see that whenever this term called displacement is mentioned, it is nothing but the direction is already included from A to D. So in that direction only it moves and the total time taken. So conversion, so these are like important because day to day we need not move, like time will be varying in hours. So when you start from Bangalore and go to Hyderabad, so there is no point in expressing the time in seconds or the distance in meters. So the relevant units are kilometers and hours. Okay, so 1 kilometer hour when we want to convert to meters per second. So this is the conversion now. We have to look at this carefully. Kilometer per hour to meters per second. So this is how we do. 1 kilometer per hour is 1 kilometer divided by 1 hour. 1 kilometer is 1000 meters. So kilometers to meters I have converted. Kilometers. Let's change. Yeah. So this kilometers I need to convert to meters. This hour I need to convert to seconds. So kilometer is 1000 meters. 1 hour is 60 into 60. 3600 seconds. So 1000 by 3600. These zeros are gone. This is gone. I get 10 by 36. When I simplify 10 by 36, so this when it's simplified, it gives me 5 by 18 meters per second. So therefore, 1 kilometer per hour is 5 by 18 meters per second. 2 kilometers per hour is 2 into 5 by 18. So therefore, every time you need not work it out, the whole thing. One need not work out this way. Just remember that 1 kilometer per hour Just remember that 1 kilometer per hour is 5 by 18 meters per second. 2 kilometers per hour will be 2 into 5 by 18, 3 kilo. So this is the standard conversion you need to remember. Now the same thing, if you want, now we have seen kilometers per hour in meters per second. If I want 1 meters per second to be expressed in kilometers per hour, so what do? Just cross multiply, and this is what we get finally. Similarly, 1 meters per second will be 18 by 5. This 18 goes up, 5 comes down. So 1 meters per second will be 18 by 5 kilometers per hour. So this is how it will be. 2 meters per second is 2 into 18 by 5, 3 meters. So this is helpful because whenever we are working out numericals and when they expect us to convert, suppose a question is given in kilometers per hour, the speed, and you want to work out in SI unit. So therefore you have to convert to meters per second, for which you need to know this conversion formula. So therefore these are like two important things that need to be remembered. 1 kilometer per hour is 5 by 18 meters per second. 1 meters per second is 18 by 5 kilometers per hour. Right? So far, hope you are clear with this. So again, 1 meters per second or 1 meters per second, this is a way of writing. Similarly, 1 kilometer per hour or HR minus 1 you can put. So module 6 will discuss few numericals and then discuss this concept of acceleration and then wind up this lecture. So just look at this numerical. An object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. So it is traveling part by part. So it moved 16 meters A to B in time 4 seconds and then moved B to C another 16 meters in 2 seconds. What is the average speed they are asking? What will be the average speed? Just now we have seen the formula for average speed is, average speed when I want to calculate, total distance by total time. Do you know the total distance? It is in 2 segments now. A to B 16 plus 16. I know. Total time I know. 4 seconds plus 2 seconds. Calculate the values and take the ratio. We get the value of average speed. The next one. Usha swims in a 90. So some of these are given in your textbook. You can have a look at it. But don't look at the solutions initially. Just try to look at the question, try to understand and then check for the answer. Now, look at this question. Usha swims in a swimming pool of 90 meters. She covers 180 meters in 1 minute by swimming from one end to another and back along the same straight path. So, let us say for example, this is one end of the swimming pool and this is the other end of the swimming pool. So, the whole thing will be pool which is 90 meters. So I call this end A, I call this end B. So she covers 180 meters in 1 minute, which means what? She went from A to B and then, so she went like this and then came back to the point A. Find the average speed and average velocity. Now average speed formula we know, total distance by total time taken. Average speed. So therefore what do? 90 plus 90, because this is the distance. So she moved from A to B and then from B to A. So average speed will be 90 plus 90 divided by the total time taken. For example, let's say that she took around 40 seconds. So she moved from A to B and back to A. So therefore distance is AB plus BA, that is 90 plus 90 in 40 seconds. Okay, so ratio of this will give you the average speed. Now average velocity, she started from A, reached back the point A. So what is the displacement? For average velocity we have displacement divided by time. So this is the formula. She started from A, came back to A. So initial and final points are coinciding. They are same, which means the displacement is 0. So 0 by time, when you calculate the average velocity, see, look at this now, just because we are getting to the directional point of view. So we are talking of the directions now. She went and then she came back to the same point. So the average velocity is defined by the direction and the displacement parameter. So since the displacement is 0, we see that the average velocity is 0. Average speed is not 0. So this is her speed. But finally, when she came back to the same point A, she started from A, came back to the same point A, because displacement is defined as 0. When we calculate the displacement as 0, the average velocity turns out to be 0 now. Which means the directional dependent point from the direction point of view, there is speed, but there is no velocity. So when we include direction, the average velocity is not there. Without including direction, we see that the speed is calculated in this particular way. And now this is a very, very important numerical, because this sometimes tries to confuse our understanding. Have a look at this now. Abdul, while driving to school, computes the average speed for his trip to be 20 kilometers per hour. So he is going to school from home. Say for example, both are along the straight line path. So this is his home and this is his school. So he is going from home to school, and he calculates that the average speed is 20 kilometers per hour in the initial direction. On his return trip along the same route, there is a less traffic. So there is less traffic now. Look at this. So which means what? There is a scope for him to increase his speed, and the average speed is found to be 40 kilometers per hour. They have never specified the distance between home and school. We don't know. We call it X. The distance between home and school, we don't know. We call it X. They have not given the time also. They are asking us to calculate what is his average speed for Abdul's trip. So he started from home, he went to school, and from school he came back to home. If the speed was maintained constant, we could have just taken average. But because speed is not constant, initially it was 20 and later it became 40, which means the times are varying. Though the distance moved is constant, the same distance is moved, but he is moving in different times. So, equal distances in unequal intervals of time, non-uniform motion. So, therefore, now we need to calculate the average speed for Abdul's trip. Okay, now what is the time taken from home to school? They have not given, but we have to calculate. So, the distance travelled, time is distance by speed. Distance, we know x by speed is 20. Time taken from school to home, the return trip, same distance by speed, it will be x by 40. What will be the total time? Total time is nothing but time taken from home to school plus time taken from school to home. This will be the total time. This is home. Okay, the total time will be time taken from home to school, time, this time plus this time, x by 20 plus x by 40 it will be. So, I know the total time. So, the total distance is x plus x, 2x. This is the total distance travelled by him. The total time, x by 20 plus x by 40. Now they are asking the average speed for the trip. Average speed will be what? Total distance 2x divided by, so average speed is 2x divided by x by 20 plus x by 40. If you carefully take the LCM for this and then do the exact, find the correct ratio, the x terms will cancel. The x term will cancel and finally you will be left with the final value of his average speed from home to school and back to home. So what is his average speed? Because the times are varying now, x by 40 and x by 20. We can never take we cannot do 20 plus 40 by 2. We cannot take the average. And if you calculate the average speed that you get, it will never be 30 kilometers per hour because it's not uniform. So once when speed is Like when the traffic is more, the speed becomes less. When the traffic is less, his speed was found to be more, non-uniform motion now. So therefore in that particular case, just the total distance by total time. If only it was uniform, then we know what to do. Now finally we come to this term called acceleration. So we started with distance. And then we saw that distance by time will give us speed, distance or displacement. The ratio of these will give you speed or velocity. Now, if you take the rate of change of velocity, and that will give us something called the acceleration. Throughout the book, we find that the terms like speed and velocity, they will be sometimes very casually used. But ultimately, we should know that whenever objects are moving, they are moving in a specified direction. So therefore, mostly we will be talking of displacements only. We will be talking of velocities only. So displacement, how it changes with respect to time will give you velocity. Now how velocity changes with respect to time in a given direction. So we are moving on a straight highway. And then in a given time, so between 1 and 2 seconds, my speed changed from 20 to 40 kilometers per hour. And then between 2 and 3, in the same 1 second time, so initially between 1 and 2, it changed from 20 kilometers per hour to 40 kilometers per hour. And then what happened? In the next second, from 40 I went off to 90 kilometers per hour, because the highway is so very clear and there are no obstacles. So therefore, I have increased my speed in the same given time. So as the time kept changing uniformly in the same 1 second, so at the end of 1 second, okay, I had 20 kilometers per hour change. Now, then I went 20 to 40, and then I went from 40 to 90. So therefore, we say that the body is accelerating. Accelerating means what? It is increasing its speed with respect to time. So change of speed with respect to time or rate of change of velocity is called the acceleration. So we introduce another new term called acceleration, which is measure of the change in velocity of an object per unit time. Means what? Rate of change of velocity. How velocity is changing. Suppose velocity is keeping on decreasing as the time progresses. We say that it's deceleration. When you put brake, we know the objects will reduce speed. So what is moving at 90 kilometers per hour eventually comes down to 70 or 50 or 20 and then finally stops. So acceleration is nothing but change in velocity. So therefore, we use this term called accelerator. So when we give an accelerator, when we raise the accelerator for a bike, what happens? We increase the speed and go. The moment you put brake, we say that we are decelerating, we are reducing. So therefore, acceleration is nothing but change in velocity per time taken. Now look at this. Velocity of an object changes from initial value. Let's say that initial velocity is u and then final velocity is v. It's changing from u to v, so on. So the acceleration is defined as change in velocity, how much it changed, v minus u in the given time. So acceleration is nothing but how an object increases its velocity or reduces its velocity in a given unit time. The SI unit now we know. Change in velocity, meters per second divided by time taken is second. So meters per second by second, it will be meters per second square, or ms minus 2 we can write. So now we know we have completely specified a motion. We started with the distance or displacement. What is the rate of change of that? We saw the terms like speed and velocity. So we had displacement. You take the rate of change of displacement, we have speed. And now at what rate the speed is increasing or reducing, this term like velocity will give us. So with these thoughts, we'll wind up the lecture, this particular lecture, and then try to go through the numericals which are being discussed here and few other numericals from your book before we meet with the next lecture on graphs. Thank you.